What's going on? I'm Anastasio Dalde. This is SDG Labs. I'm the world's best dad, hands down. I've got a shirt that says so. So what I did was I've talked to you guys about domains, and we've talked to you about the idea of domains. It's kind of this idea of what is allowed within the X variables, what's allowed to be inputted to this. Well, mathematically speaking, there's actually a really easy way to figure it out. So let's take a look at a few functions and kind of think about their domains. We're going to look at y equals x squared. I've already shown you this graph right here. It looks like a parabola, and it pretty much has no domain issues. Also, y equals mx plus b. This is a linear graph. Depending on what b is, that would give you, the different height of that thing. And that one also has no domain issues. There's no problem as far as which x values I can go with. We have maybe y equals x cubed. Let's do that one. That graph looks kind of funky. It almost looks like I took part of this parabola and went and broke it and then kind of flipped them upside down. Still no domain issues. There's no problems as far as which x values I'm allowed and not allowed to have. Here's another funky one. What about the cubic root of x? Y equals cubic root of x plus 1. I don't know. Let's make it 2x plus 1. 2x minus 1. Alright. Well, if we were to graph this, that would look like, I don't know, it would probably look something like, wait, the minus 1 is going to move it to the right, and so I bet you it would probably look something like this. And again, there are no x boo-boos. There's no restrictions on what x values I'm allowed and not allowed to have. And then one last one I'm going to do is, what about the absolute value of x? Y is equal to the absolute value of x. Well, that one looks like a straight line, except the negative side gets reflected, so it kind of looks like this. It looks like a triangle, like ding, or a ray of light going beep, 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 beep. Still, no restrictions on the x. The only ones that I've introduced you to so far, and really it's the only ones you're going to have to worry about, is these two right here. It's the y equals the square root of x, which that graph looks like that, and then also y is equal to 1 over x, which that graph looks like this. Alright. Usually you don't need to write the square root. I just wrote it up there because there used to be a cube root. I had a cube root earlier here on the board, and we just don't write the square root because we're lazy. You just assume that it's supposed to be a square root if you don't see another number up there. But what were the problems when we had here? Well, the problems were you can't have negatives inside of this square root. This square root is not allowed to have negative things inside of it. So no negatives inside the square root. Alright, the last one, or the second one, you're not allowed to have zeros in the denominator. No zeros in denominator. Now, I'll be honest with you, it's kind of that's really all the rules there are. It's pretty straightforward, it's pretty simple. That's the only two things I want you to remember when it comes to solving domains. No negatives in the square root, no zeros in the denominator. Here's how you apply those rules, because they're pretty straightforward and easy. Or at least I think they're kind of easy. Alright, let's do this. Alright, let's try y equals 2x plus 1. Alright? Y equals 2x plus 1. Are there any square roots? No. No, let's not deal with that rule. Are there any fractions? Because fractions would have a denominator, so therefore it could have a 0 in the denominator. No. Oh, there's no domain problems here. Oops, I wrote down the wrong one. What about y equals 1 over 2x plus 1? Are there any square roots? No, there aren't any square roots. Are there any denominators. Hence, are there any fractions? Yes, there is a fraction, so you could have a denominator that's 0, so there could be a problem here. So what I usually do, and I like to do this, I circle the denominator and I say, well, this 2x plus 1, whatever's inside of that circle cannot equal to 0, because the 0 is not supposed to be in the denominator. The denominator can't be equal to 0. So what can I say about it that's true? Well, I can say that it's not equal to 0. All right, then you can say that you treat it like it's an equal sign, so 2x is not equal to negative 1, so x is not equal to negative 1/2. Because if I plugged in negative 1/2 into here, I would get 1 over 2 times negative 1/2 plus 1. That 2 times negative 1/2, this becomes just negative 1. Negative 1 plus 1 is 0, so I'll have 1 over 0, which is a big problem. So your domain is such that x can be anything except x is not equal to negative 1/2. If you want to write it in set notation, you would probably write it in something like that. And that's my answer, and that's what I'm going with. Now, how do you deal with the one that has the square root? Let's do that one. What if we said, all right, well, what is this then? What's the domain of this thing right here? So what I do is I say, all right, well, the problem that I'm going to have, the rule that I'm going to break here, or I could potentially break here, which I don't want to, is I don't want to break the rule of having a negative in the square root. So I'm going to circle everything that's in the square root, and I'm going to say, all right, well, 2x plus 1 has to be bigger than or equal to 0. It has to be bigger than or equal to 0. Because any number that's bigger than 0 is a positive number. And if it's equal to 0, it's also a non-negative number. So that's true. So let's see. 2x is bigger than or equal to negative 1. And then x is bigger than or equal to negative 1/2. That's my answer. So x such that x is bigger than negative 1/2, that's my domain. Because all of my numbers has to be bigger than negative 1/2. If it were smaller than negative 1/2, well, let's try that. Let's take an x that is smaller than negative 1/2. Negative 1. So if I have x equals negative 1, I'll have the square root of 2 times negative 1 plus 1. I'm just plugging negative 1 into here. That becomes negative 2 plus 1, which becomes the square root of negative 1. That's a problem. So your domain is all the numbers that are bigger than or equal to negative 1. Shoots, bro. Up out.